In this video, we're going to give a demo of the correct working versions of lab13. Okay, so let's take a look at, so it's in the list here somewhere. Let's take a look at lab13, the description. Okay, so first you're going to create your lab13. If I see typos, I will just fix them as we go. So we're going to create our lab13 directory. I'll give, let's see, I'll give a demo of this in my class account as well. So if I do a lab check, it complains about the new lab13 directory. And then these are starting points. So each of these are examples that we looked at in the previous three, somewhere in the previous three lecture videos. Those will be the starting points. We'll make modifications, so I'll go ahead and do each of these. Those files should all be there now, right inside of lab13. Now, what the lab check is going to do, if it works the way I think it will, it'll check each one of these files on a series of inputs, and the first one that your program is wrong on, it'll give a message. Okay, let's fix that. Try again. Okay, so I believe this is what we were supposed to see. So for the first one here, it's complaining about the input empty strings. That means no command line arguments were given. And my program is just the same as the convert check program from class, which gives this message. And it's supposed to give this message. So I can go ahead and put that in there. So this was the conversion program from class that does Fahrenheit and Celsius, but this is now going to be called lab13 1, and this should be inches and centimeters according to this message. Okay, so now with lab13 1, it's complaining about the input 1, 2.54. This would be 1 inch and 2.54 centimeters. It should say that's correct. This is still doing the conversion from Celsius, so now you need to go in and make this, change everything here to do Celsius, or to do inches and centimeters instead of Fahrenheit and Celsius. And then you go through and do the same process with the other ones. Let's go ahead and look at not the code for the correct programs, but for how they work. So I'll run mine. The first one is this conversion. I think this one's pretty easy to guess what the right output is supposed to be. So if I say 1 and 2.54 centimeters, then it should say that's correct. If I say 2.54 and 1, it should say that's incorrect. And then it gives me the correct answer. And still, there should be if it's within a tenth If the conversion is within 1/10 of correct, then it'll still say it's correct. Alright, that's the first one. The second one is doing the operators program, and the way the operators program worked was we said something like 4 plus 5, and then it would be evaluated. So for this, all of these should be added in as operators. There's times, divide, and, which is kind of interesting the way and works. So this is a Boolean and. What it appears to do is if both of these are not 0, it gives you back this one. The second one. If one of them is 0, then it gives you 0. If we change this to or, if either one of these is not 0, it gives you one of them. Okay, so that's the and or. Then we have less than, which gives back true or false. If we say 7 less than 7, what should it be? Should be false, but if we say less than or equal to, that's true. And then you also need to put in the not equal to. Is 7 not equal to 7? False. Is 7 not equal to 8? Right. Yes, so that should be true. Alright, if you look at the example that was this coming from, basically you're going to have to add in more else if conditions here. So that's all you should need to do there. That's pretty easy. Alright, the next one is the rectangle. So with the original rectangle, we gave it a width and a height, and it printed a certain number of stars. With this one here, it's printing dots instead of stars, and it's printing a 3 by 3. There's only one parameter here, so it's doing 3 by 3. So it has a 3 by 3, but first it prints a 2 by 2 and a 1. I go to 4, it prints a 4 by 4 and a 3 by 3, a 2 by 2, and a 1 by 1. And if we look at the code for that you're starting with, first of all, you're only going to have one command line argument. Change this statement. This should be a 3. Then this part here is the part that creates the line and then prints the rectangle. So this is going to happen inside of a loop. So you have another loop here. So start a loop here, have this part be inside the body, and then you have to work out what changes with the different variables and things. Okay, so that's step 1 with the rectangles. Once you get that working, the fourth part, there's a mistake there. So the fourth part is the same parameters, but now you have hollowed out squares. And there's no need to worry about that really until you have this picture done. The way to think about doing this one, once you have that one done, is for each individual character, if it's on the first row or last row of a block, it gets the character, the dot. If it's in the first position or last position on a line, it gets put out as a dot. Otherwise, it'll be put out as a space. So that would be this L equals L plus star. There would have to be some conditions there about whether it's in the first or last column, and then you'll have to do something to work on the first and the last row, making differences for that as well. Okay, so that's number 4. Number 5 is starting with the addition table that we did in class. And there's an extra parameter. If we put a plus, so there's a 5, so it goes addition up to 0 up to 5, 0 up to 5. And then there's an extra parameter here to say what the operation will be. If we put plus, it's the same as we had in class. Put minus, then here we'd have 4 minus 0 is 4, 4 minus 2 is 2, and so on. You can put times. There's times. If we put divide, we'll get things that, for example, so 0 divided by 0 is undefined in JavaScript, and anything else divided by 0 is infinity or negative infinity, so those get printed. You don't have to do anything special for that. If you just don't check for dividing by 0, that's what will happen. And in JavaScript, 1 over 3 would be 0.33333333 repeating. So to make that not print so long, it would be maybe 10 or 15 threes, digits there. You should use the toFixed function. So if we have a variable value here that is some number, we can say value equals value dot toFixed parenthesis 2, and that'll cut it off at 2 decimal places. So you need to do that to be able to match the output on the divide. Also, I increase the width on these columns. If you count, there are 5. There's a variable number width in the file, so we can go ahead and look at that one. This number width here should be 3 instead of, or should be 5 instead of 3. And then you want to look for where does the addition actually happen here. And there you would need to have an if test depending on adding another parameter. So there should be another parameter, another argument here. And you should need to save that, and then depending on what it is, wherever you do the adding in here, that should be multiplying, subtracting, or dividing, depending on how they run it. I'm also increasing the points here, so these last couple homework assignments will be, and lab assignments will be worth more because they're more important and more difficult, and it's not okay to just give up. You want to keep working until you get it right. Alright, good luck.